Gang. I'm curator of horticulture at the University of Melbourne System Garden. In honour of Botanic Gardens Day, we are visiting botanic gardens across Victoria to, among other things, understand a little bit more about education, horticulture, conservation and community engagement. I hope this is an opportunity for people to learn a little bit more about botanic gardens that they didn't already know, and encourage them to go out into botanic gardens and appreciate all the value that they can provide.
Botanic garden for me is obviously a great collection of plants, but beyond the individual plants and their scientific value is the notion of botanic gardens as very special social places as well. We have a number of groups who come to our gardens, or are very welcomed to our gardens, from high school students. We've got a beautiful local high school who come to our gardens to, they study photography. So they're using our garden as a venue to come and find beautiful things to photograph. Basically, we're really trying to encourage children to look and be in a garden in a particular way. And what we try to do is role model the way we'd like people to be in the garden in terms of interacting gently with the space. But really we're trying to foster a love of plants and a connection to the garden.
The best thing about a botanic garden is that it holds all those collections of plants, that you can come here and visit the world without having to travel anywhere else. That you can come here and visit plants that you wouldn't see in your backyard, you wouldn't see in your local area. So we're in a process of expansion and building. So we've just created our Garden for the Future, which is under 12 months old. We've also got the oldest public garden in Bendigo as well. So our heritage garden is over 160 years old. So hopefully we'll be replacing some of the older trees in the gardens in the heritage section. We'll also be joining the new garden with the old, so there'll be a new transition zone between the two gardens.
I think the really great botanic gardens are botanic gardens that are hubs. They're social hubs, they're environmental hubs, they're conservation hubs, they're horticultural hubs. The role of botanic gardens in conservation, what we're doing with BGANZ Victoria is looking at establishing conservation collections in a number of regional botanic gardens across the state of Victoria. But for that project to be sort of driven and supported by the Royal Botanic Gardens Victoria. Essentially what we're doing is we're going out to regional botanic gardens, we're working with the gardens curators and gardens managers on an approach to establishing collections of rare and threatened plants that are significant to that particular area. And then the RBGV will actually propagate all that, collect, source and propagate all that material, and then distribute that material back out into regional gardens.
So a botanic garden, for me, means that it's a place for people to firstly enjoy, but then it has all those other benefits of labelled plants, documented collections of plants. The importance of botanic gardens to communities, I believe, is that it gives them a sense of pride, it gives them a sense of place. And we've had people come on guided tours here, and one particular comment said the Melton Botanic Garden has put Melton on the map. To a large extent, this garden is the community, because the people have been the ones pushing it, backing it. The feedback we get from people who are visiting, walking through, doing recreational activities here is just fantastic.
A community space.
It's a garden to display a collection or a variety of plants.
What is a botanical garden? The most beautiful place to come to.
It's a wonderful refuge for the community and for visitors.
I think the free access is the best thing.
For me personally, it's the joy that it brings to people.
Everything, I guess, we need plants for everything to live, really.
Education, conservation ideals and public enjoyment.
Knowledge and inspiration and understanding.
Well, I'd be biased and say the Eramophilas.
Banksia.
Oh, in Australia, red gum trees.
A plant with gum nuts in it.
It's the Eucalyptus.
Eucalypt.
Eucalyptus gum tree.
Botanic Gardens Day is the last Sunday in May, so put it in your diary.
Well, good evening, everyone. So happy to be coming to you with this, the fourth of our May Thursday evening BGANZ chats ahead of Botanic Gardens Day, which is this Sunday. It's incredible. We were talking about it. May seemed a long way away, and here we are just a few days away from Botanic Gardens Day. Big hello to everyone who have joined us so far. We have Katja, who's over in Oxfordshire in the UK. We also had Tyler Howard, who's joining us from the Chelsea Flower Show. We've got visitors from Scotland. We've got people coming in from all around the country. So if you want to drop into the chat, what country you're on, on the lands of which people, and I want to acknowledge the lands and the elders, past, present, and emerging, of all the countries that we are broadcasting from and to. Acknowledge these countries, and the fact that, as this whole series has talked about, we're caring for country. We're caring for the plants, the animals that need the plants, the insects. Everything about our conversations leading into Botanic Gardens Day is about caring for country, which has been done for so long here in Australia by our Indigenous peoples. So a big welcome, everybody. Sally McCraith over there in Scotland. Lovely to see you joining us from over there. Let's have a quick little look at where people are coming in from. Karen's on Gubbi Gubbi country up on the Sunshine Coast. Spencer is also on Gubbi Gubbi country on the Sunshine Coast. Dharawal country here for Tom. Redleaf at Lake Macquarie. They're on Awabakal country up near Newcastle. Mildura has the Australian Inland Botanic Gardens. Thank you, Christopher Harcom. Waves from Nairobi, Miazi land. Wow. So we really have a wonderfully international crowd rolling in today. Thank you, Robin. You're also on Gubbi Gubbi. And where's Linda? Judy. Judy's joining us from the far south coast on Jurunjeri. So a big welcome to you too, Judy. Before we get underway, these talks and Botanic Gardens Day have been supported by the sponsors: Seasol, Augusta, Plant Health Australia, the Australian National Botanic Gardens in Canberra, and also the Royal Botanic Gardens in Victoria. So a big call out to everyone involved behind the scenes. The production team, we've got Tim Ubagam, John Arnott, Radine Koof, Alison Morgan, Helen McHugh, Eamon Flanagan, Rebecca Harcourt, and Jill Scown. Thank you. A big thanks to all of them for making this happen, bringing our guests up over the 4 Thursdays. I've had an absolute hoot doing this, and I feel like we're ready to rock with our last one, which, as I wrote in the post, all aboard. I need you to put your seatbelts on, please. Just strap them down. It's a bit like an aeroplane. We need not just a sash belt. We need them over the top, because we're going on a journey. We are going on a very serious journey. And to take us on that serious journey is Professor David Cantrill. He is the Chief Botanist at the Royal Botanic Gardens in Victoria. And we're going on a Paleobotany Gondwana tour. So put your goggles on, get your seatbelts on, and join the TARDIS, because it gives me great pleasure to welcome David, who is right here. Here he is. David, great to see you.
Great to see you, Costa. Yeah, great to be here. It's been a really fantastic 4 weeks, and bookending it for me is well, a bit overwhelming really, but we'll see how we go.
No, I have no doubt. Now, everybody, I hope you can appreciate that when I first saw David in the green room about 20 minutes ago, my dream came true. My post came true, because I said, all aboard, we're getting in the TARDIS. We're going to fly back in time. And David has his pilot's headset on. His voice is coming through as though it's the captain speaking from the cockpit. We are in awesome hands. So, David, to kick things off, what I've asked all our guests on each of the Thursday nights is, can you share a little bit of where the ignition happened for you to get into plants and horticulture? Because your journey has been phenomenal to where you've been. But what was it? Who was it? How was it? Roughly when was it that all of this came together and brought you to that journey that you set off on?
Yeah, I guess it started at a really young age, because I was, my dad was a horticulturalist and did garden shows on the radio, and we used to spend a lot of time in the bush. So I became very interested in the environment around me and plants in general. And then when I went to university, became interested in geology. So it just seemed to be the natural thing to marry those two interests together and start working on fossil plants. So that's sort of the ignition point for this really big long journey I've been on.
And I read a little bit about sort of your bio, just as a setting before we take off, because we're taxiing here before we start to take off into the time machine backwards. And I really like that idea that we're just going that way. Give us a little bit of a background about where that road has taken you and some of the things that you've achieved and moved into.
Look, I've been so lucky with my career and what I've done, and been to all sorts of places around the world studying plants and plant fossils. Initially, when worked in Cambridge in the UK for the British Antarctic Survey, and did a number of seasons in the Antarctic discovering new floras down there, new fossil floras, and describing them. And from there, I then moved to the Swedish Museum in Stockholm and spent 5 years as a senior curator looking after their fossil plant collection, which was one of the biggest collections in the world, I would say, and it has huge global coverage. So that was a real privilege to do that and look after that collection and curate it and position it so it's better for the future. And then I've just had a fantastic opportunity to return home and work at the Royal Botanic Gardens in Victoria, where I head up the science division, and we have the National Herbarium. We have a really important collection of dried plants that goes back to the 1500s. And that collection of plants is actively used by scientists discovering new species, working on climate change, working on conservation genetics. It integrates with our seed bank and our other conservation projects. So it's just been a fantastic journey, and looking after those collections and trying to leave them in better shape for the future is the real thing.
Wow. Do you sort of feel almost like that sense of awe around working with those collections and then adding to them, knowing that they go back so far in time, and you're almost handling these pieces of history that have sat in ice cores or sat in rock for thousands and thousands of years? That bit sort of really blows my mind as an observer.
Yeah, and I mean, the time, that's the thing that's really hard to, grapple with when you find something that's 250 million years old and it hasn't seen the light of day for 250 million years, and then you're looking after it in a collection, or you've got some material in the collection that has that, fantastic Earth history connection, but it also has a historical collection to human endeavour. You know, material collected by Scott in the Antarctic when they were coming back from the pole, for example, of, you know, handled that material, which is in the British Museum. Material that was collected in China as part of early expeditions in China, or, you know, dried plants that we have in the herbarium in Melbourne that, you know, were collected on early European exploration of Australia, or you know, material from Cook's voyages around the world, material collected by Darwin, for example. So it's the objects, but it's also the history behind the objects that's just fantastic. And, you know, yeah, it always, you know, raises the hair on your neck when you see that material, and you're caring for it, but at the same time you're using it to further our knowledge.
Yeah, that's the bit that sort of gives it the license, isn't it? Because you're not just ogering over it and going, wow, this is 250 million years old. It's like, how can we use this data to combat and deal with and come up with solutions and directions for the future?
Yeah, that's absolutely right. And, you know, for the fossil material, it's about understanding changes in Earth history. So, you know, we have a very small window on climate change, and we can see the impacts of that. But the geological record has a profound and deep history of climate change. And by looking at these plants, you can get a sense of what impact the climate change has had on the biota and the forests and things at that time, and how it's changed to, you know, to give us what we have today.
Yeah. Now, I'm super keen to get into your presentation, and I think Jacob Bond has said what I think we've all wanted to take out of my analogy. Strap in, everyone. Thunderbirds a go. So, David, I'm going to throw the your presentation up on the screen, and it's over to you. And let's go.
Great. Well, thanks very much, Costa. And it's really tonight, it's a journey back through time, but a journey that looks at the Australian flora in particular, and how we might connect that. And many people, you know, in this country will be aware of things like Gondwana Link and the Gondwana and rainforests of Australia that are World Heritage listed. But what I thought tonight would be interesting to explore, what does that mean? What is Gondwana, and what does it mean for the flora? Because when you think about the Australian flora today, and when you experience it, as a botanist, you'll note that there are a few plant families that are really dominant in the flora. The Myrtaceae with the Eucalyptus, the Mimosaceae or Fabaceae with the acacias and related things, and of course Proteaceae is a classic iconic group as well. And of course, some of those we talk about as being Gondwanan, you know, they're Gondwanan lineages, and some of the old things, the lineages and groups of plants that are in the rainforest. So, you know, what does that really mean, I guess? And I just wanted to sort of explore that. And to explore that, you really need to go back in time about 250 million years. So I want us to sort of relax, take a deep breath, and travel back 250 million years.
Would anyone like anything from the trolley? I'll just push the trolley past, and you know, if you'd like a cup of tea or a coffee or something, because we've got a long journey. Here we go.
We've got a long journey, and I think you probably need to stow your tray tables and make sure your seatbelt's nice and tight. But while you're doing that, we've got an image up of, or a cartoon up of, what we think of as Gondwana, and you'll see that it's several different continents in quite a different configuration to the current world. And one of the bits of research that was used to pull these pieces together was the fossil history of those continents, and the recognition by a number of geologists that the fossil floras and the fossil animals were common to those areas. And if you think about terrestrial things, you know, plants, terrestrial plants, trees don't swim very well. So the implication, of course, was that if those species were common to those areas, then they must have been connected in some way. And that comes to this concept of Gondwana. Gondwana is actually an area of India, and that's what it's named from, an area of central India, which is a little bit ironic, as we'll see later. And it refers to a whole sequence of rocks there that geologists study called the Gondwanan series. So that's the continent as it looked 180 million years ago. But as we've moved through time, continents move around through a process of continental drift. And so if we start off at about, 100, 110 million years ago, and having a look at the poles, this is what the world would have looked like. And you can see that Gondwana at this point has broken into a number of pieces that will become Africa, and you'll note that India's disappeared way over the horizon. It was something that sort of broke off and then moved northwards. So when we think about our flora today and the flora of the world, those big continental movements carried and rafted the floras, and they couldn't reconnect, and so they would take their own evolutionary path. And that evolutionary path is largely controlled by the climate zones they pass through. And of course, as the continent breaks up and into these component pieces, the ocean circulation patterns change. And as those ocean circulations patterns change, the climates of different regions change. And so one of the prevailing patterns that we see is the increasing isolation of Antarctica over the poles. And as we develop a circumpolar current around the Antarctic, the development of ice sheets. And the development of ice sheets weren't very good for the flora that was on there. So today there are only 2 vascular plants on the Antarctic, and so everything that was on the Antarctic was obliterated by that process of continental drift and climate change. And what that means is when we're trying to understand the distributions of plants and animals across the Southern Hemisphere, our window into what happened in Antarctica is really constrained to the fossil record. And that's sort of where the work I've been doing comes in. But before we talk about that, I just thought it'd be worth talking about a little bit of history. And so I put this guy in, Joseph Dalton Hooker, was director at Kew Gardens, but importantly he sailed on the James Clark Ross expedition in 1839 to 1843. And this sailed all around the world, but it's particularly around the Southern Hemisphere. And one of the things that Hooker noted was that the floras of these regions were very similar. Here are plates out of his treatment of the plants that he saw on that trip. It's images of Nofaphagus, Antarctic beech. And that today is found living in South America, Southern South America, New Zealand, Australia, New Caledonia, and up into New Guinea. There are a whole range of other plant groups, but this one sort of really illustrates the work that he did and the interest he had in plant geography at the time. And he noted that the similarity of the southern floras probably meant that they had a common history and were connected at some point in the past, as in connected and part of that Gondwanan flora. Now, the interesting thing was just a little bit of a side trip on this journey was James Clark Ross's expedition penetrated well into the Antarctic, into the Ross Sea, and into the northern Antarctic Peninsula. And this is an illustration out of the volume of a place called Coburn Island. And it's one of the few places that they landed in the Antarctic. I've been very fortunate to visit there. This is Coburn Island today. You can sort of see the similarities, the high peak that they had is, shrouded in cloud there. And Joseph Hooker collected a few lichens from there, and that's sort of some of the earliest records of plants from the Antarctic. The unfortunate thing was if they'd landed on Seymour Island, which is right next door to Coburn Island, pretty nondescript island, pretty flat, pretty uninteresting, but it has one of the best fossil floras in the Antarctic for understanding these things. And yeah, you can just sort of wonder what it would have been like, a bit of a time experiment if you think if they'd landed on Seymour Island instead of Coburn Island, things might have been different.
David, just at that little pause between slides, I just want to bring to everyone's attention that we do have a sponsor's prize to give away today, and I will be making one question. So listen carefully to David's presentation. There's so many drop mic moments already. Look at the notes I've taken. I'm going to have to ask 10 questions for the one prize. The first person that gets in will get the prize. So yeah, just bear that one in mind as you walk up and down the aisles of the plane looking for a cuppa.
Yeah, make sure you take plenty of notes as well. But I'll just continue with some of the spectacular fossils that we see there. So I've put 2 images up. I've been very lucky to work in a number of different places in the Antarctic over the journey. And the picture on the left is something that always really strikes you. Here you can see a fossil tree embedded in some river sediments. So this tree is 140 million years old or thereabouts. And it was buried by a large flood event. And it's interesting when you see that, the cliff it stands in, and then the whole landscape is just white around it with ice and not a plant to be seen. And that was something that, you know, Scott and early explorers noted when they were in the Antarctic, this juxtaposition of this icy environment today, and yet in the past it had these trees on it. The image on the right is another fossilized tree, and you can see here the detail that we get preserved. So you can see impressions of the bark on the top part, and you can see those whorls of branches or branch scars around the middle of this trunk. And this material's petrified, permineralized, so you can cut a section and you can see the growth ring, so you can see something of the climate history. And we know from the sections of the wood and from that growth form that this belonged to a group called Araucaria. So it was in the Araucariaceae, the monkey puzzle trees, which is another group that's like Nofaphagus, is found on those southern continents. So you've got 2 species in southern South America today, South America and in the Atlantic rainforests, and then you have that group in Australia and in New Caledonia, and close relatives like Agathis, the kauri pine in New Zealand, and New Caledonia in Australia and New Guinea, and up into Southeast Asia. And I'll come back to that distribution a bit later. Now, going alongside wood, and wood is, you know, preserves easily, but it doesn't have a lot of information in it. You can gain more information from foliage and other lines of evidence, and I've just popped up 4 British Antarctic Territory slides if you're a philatelist and you like collecting stamps. And these are all specimens I collected in the early 90s. And again, they show some of the species that are in this, show those connections across those southern continents. In particular, I'll just give an example of that one that's in the top left, the Lophosauria cupulatus. This fern, it has very distinctive spores and is related to a living, there is a living species in this genus, Lophosauria quadrupinata. It occurs in southern South America today, but it gets all the way up into the Caribbean. And it shows how adaptable plants can be. So 100 million years ago, it was widespread in the high latitudes, near the southern pole. But as the Andes rose up through these plate tectonic processes, it was able to occupy that cooler climate window and climb up the side of the Andes and get into the Northern Hemisphere. So that sort of thing shows how adaptable some of these plants are and how they can get around, but also the processes that they need, the long time scale processes for them to be able to move and colonize other areas on evolutionary timescales. And that's how we, they're the sorts of timescales that we think about when we're thinking in evolutionary terms. As the climate cooled in Antarctica, the flora got more and more depauperate. We lost a lot of species and the fossil record diminishes. And really the last fossil record in the Antarctic are these leaves, which come from the Beardmore Glacier, about 100 miles from the pole today. They occur in glacial sediments, so there's glaciers all the way around them. And when we compare them to modern things, this particular group belongs to that group that Hooker collected, Nofaphagus. And these were the last sort of, real small tundra-like forests that existed on Antarctica. So Nofaphagus has had that long history across those Southern Hemisphere regions. As I said, here's an example of Nofaphagus growing close to glaciers, and you can almost see how the leaves and those glacial sediments could all be interleaved together as they were in the Antarctic several million years ago. So it's really a great opportunity when you travel to these places to see the ecology, see how plants grow, and be able to draw on that to interpret the fossil record that you've seen. So what I want to turn to now is I want to turn to what happened in Australia and what is Gondwana and what is a Gondwanan flora. So if we think about that common flora that was across these areas, that's really what we should be thinking about in terms of Gondwana. So the Gondwana flora was on Gondwana prior to it breaking into its component pieces. And it's, as I said, it's a bit ironic because Africa and India are part of Gondwana, yet they lack all these things that we call Gondwanan plants. And that's because those two bits of Gondwana broke off before those groups evolved and disappeared over the horizon and were separated by oceanic basins. So if we look at Nofaphagus, for example, there are no records of Nofaphagus in Africa or India. Nofaphagus evolved after Africa and India split off from the continent, and that's why you only get Nofaphagus fossils through South America, New Zealand, Antarctica, Australia, New Caledonia, and up into New Guinea today. So the question, of course, is Nofaphagus really Gondwanan? And in a strict sense, you would say no, because it isn't on all the Gondwanan fragments. But as a communication piece with the broader community, it's a useful concept to think of these things as being Gondwanan. And in fact, most of the lineages that we regard as Gondwanan are really this, what we'd refer to Eastern Gondwana, and aren't at all connected to Africa and India. And so if we had that common flora, what happened to it? How did it change? And why is Australia's flora so different from South America or New Zealand? And when did it change? When did, groups disappear and when did they reappear? And that's really my interest in understanding those patterns of change and when they occurred. And I've just got a couple of examples just to highlight, I guess, how things have changed and how you need the fossil record to understand that history. So if we think of casuarina, she oaks, they're a southern Pacific group really today. Yet when we look at the fossil record of this group, we can find these fantastic fruits. So, here are typical casuarina fruits. They would belong to the living genus Gymnostoma, which is found in Queensland, one of those Gondwanan lineages, yet these fossils are from South America. Sort of remarkable, really, because there are no Casuarinaceae in South America today. And we can run through a number of examples of that sort of pattern. Things like Papua cedrus. So this is a group of conifers found in New Guinea today. Close relatives in New Zealand, which is a thing called Liber cedrus. Yet here we are in South America, absolutely beautiful and unequivocal fossils of Papua cedrus. So these fossils are all from the Eocene. So that's about 54 million years ago. So 54 million years ago, we know there are a number of what we would regard typically today as Australian or Austral lineages were present in South America. But there's some even more surprising ones there, because we think of many groups as uniquely Australian. So we think of Eucalyptus. This is an Australian genus. It's a thing that dominates our vegetation, that dominates our flora, at least in the sort of more mesic areas. Yet, again, in these Eocene deposits in South America, you find these leaves. You can see the beautiful marginal veins they have. You can see the oil glands in the leaf. And then on the right, you can see cleared leaves of extant eucalyptus. And some people might say, oh, well, leaves, they're not that diagnostic. There's lots of other myrtaceae that look like that. But in these South American deposits, there are fruits. There's the typical umbels and the capsules that you see, and the scar patterns on the tops of these fruit indicates that it's in a quite advanced group of eucalyptus. So there's really good evidence for eucalyptus being part of the South American flora 54 million years ago. Yet today, it's uniquely Australian, endemic to Australia. So that tells us a lot about the changes that we see.
David,
Costa.
the details in there are phenomenal. When you're talking about looking at a fossil, I mean, I'm looking at those images and it looks like you've just literally picked them up off the ground.
Yeah, I mean, D's the one that we picked off the ground, but yeah, all the other ones are fossil ones, and it is amazing, some of these deposits, how well preserved these things are. But you need those special deposits that have great preservation to be able to work out what these groups are. And yeah, I mean, it's astounding. For a number of years, eucalyptus had been reported from South America, and everyone had discounted it because the material that was available in the early 1900s was it didn't just have enough detail in there, and people would say, oh, well, it's some other sort of myrtaceae, it's not eucalyptus. It couldn't possibly be eucalyptus. Eucalyptus is Australian. We can't have that in South America. But these recent discoveries clearly nail down a whole heap of those groups. And so, yeah, I mean, it's astounding. And so we've got a common flora in the Eocene. We share a lot of things with South America, and for some reason they've gone extinct in South America. And that's the interesting thing, to try and understand why groups that are so successful in our climate today have gone extinct from South America. And it's those lineages that you would think of as being Gondwanan. But there are other lineages and other groups of plants that I just wanted to touch on, because it's also relevant to the composition of the Australian flora. So one of the other things that we think about is, as uniquely Australian, is acacia. And like eucalyptus, it's a very dominant part of our flora, yet it isn't Gondwanan. And so the question is why isn't it Gondwanan? Well, there's no evidence of it on those other continents. It was present in New Zealand fairly recently. But when we look at the evolutionary relationships of acacia, for example, what we find is it's very closely related to Asia, there's a group called Paracerianthes, which is a genus that occurs in the tropics, and one species across southern Australia, and that is the most closely related group to the Australian acacias. And in relation to how the Australian continent's moved, so 54 million years ago, we had that common flora with South America, but as we've moved northwards, we've run into Asia. And as we've run into Asia, that's provided the opportunity for plants from Asia to come into Australia and from plants in Australia to move into Asia. And so the Australian flora, while it does have Gondwanan elements, it has elements of, a whole range of other places, particularly from the Asian region. And I think that's one of the things that's really fascinating at the moment, trying to understand that. And the reason that's interesting is we tend to think of Gondwanan elements as being the basal or the primitive groups of flowering plants. And if you read, there's a lot of literature out there in the public domain about the Gondwanan plants that are in the Queensland rainforests and other places. Some of those are ancient lineages, sure, but they weren't on the continent. So one of the groups that is reported as being a Gondwanan lineage, because it's an old lineage, is the water lilies. The water lilies that you get in Kakadu and places like that. But all those species are very closely related to an Asian group. And so while it's an old group that's in Australia, it's a new group to Australia. And that's sort of part of the challenge that we have in understanding all those patterns and understanding the heritage of those different groups across the Australian continent. So I've talked for long enough. I'm sure there's lots of questions out there, but that's a little bit of a time travel story for us about the Australian flora and Gondwana.
Oops, hang on a sec, David. I'll just bring us back to just. Oh, that's solo. How can we go back to? There we go. Wow, David, the questions have been going off like a frog in a Nofaphagus sock, so to speak. But where to begin? Okay, there's been some good band names being thrown up just as of a Gondwanan lineage is a good band name, and John has piped up with a secondary band name, Reunite Gondwana, as another band name. So you've inspired to think about the language you're using in lots of different ways. I'm just trying to think. I might work my way back, and that way we can sort of move through the aeroplane that way, rather than sort of throw all the way back to the beginning. And we'll talk our way more recent to the questions. Well, look, there was one question from Karen Freeman. Do you have one favourite discovery that stands out? That's a good question, Karen.
That's a great question.
Your favourite child.
It's a tough one. And when you've been as lucky as I have to collect fossils in all sorts of different places, I think probably the best one was probably one of those Patagonian fossils. And none of those Patagonian fossils that I showed are ones that I've collected, but I have been very lucky to go to those sites. And we were there, travelled in full four-wheel driving day at 4 kilometres an hour to get into this site. It's an old crater. It was a volcano 54 million years ago, and so there's masses of volcanic layers, and just sitting on the top of one of these piles, you're surrounded by effectively cold desert, so it's very low vegetation, there's nothing there, splitting rocks. And I split a specimen open, and it was a casuarina flower. And I just thought, wow, that's just so special. No one's seen this for 54 million years. And here I am sitting in this amazing landscape with a whole bunch of friendly colleagues, and I've just turned this over. That's just one, but there's so much excitement in it. Anytime you collect something and you split open a specimen and a rock there, and it's got something in that no one's seen for that sort of length of time. It's unbelievable.
Yeah, I think you've summed up what everyone has been saying. Just how fascinating this information that you're sharing, but the fact that you're right on that literal hammer stroke to see what the lottery is going to throw out. And Tessa said continental drift is easy enough to follow, but adding on plant migration seems a whole other layer of mixing.
Yeah, it is. It's and I mean, when you think about it, some plants disperse better than others. So you've got that layer of mixing in there as well. Some things will get blown across, oceans, and so you can find them, but then other groups are just fairly immobile. So you've got to blend that into trying to generate the understandings as well.
Yeah, exactly. Bill Blake has said, I collect fossils from a 40 million year old site north of Perth, plenty of Ukes, Banksias and Dryandras, but also Nofaphagus.
Yeah, and that's right. I mean, there's some great sites in WA that are of that age, and it's a really interesting mix when you see it, because you've got that Nofaphagus that you really today we associate with cool, temperate, moist environments, and yet at the same time you've got these plants that we associate with, more xeric and drier environments, and those are the things that are really, challenge your mind, because what was the vegetation like and what was it growing in? Because you've got those two things together, and they were clearly associated, but how does that work? Quite different vegetation, probably quite different vegetation, and having the imagination to be able to think about those things is really critical, but also going and visiting places. So here in Australia, we think of Nofaphagus forest, the wet forest with the mossy understory and, all those sorts of things, Strzelecki ranges down here in Victoria and various other places. If you go to them in Chile, the understory is bamboo. It's just totally wild. You see these Nofaphagus trees, and there's this understory of bamboo that's 4 or 5 meters high. It's not something that you would envisage. And so having those experiences helps when you see these fossil deposits that have got strange juxtapositions of different plants that are quite separated in the landscape today.
So we've got a question here, David, from Katya, and she's asked, what's your most outlandish hypothesis about the Gondwana flora that you wish you could find evidence to support? That's a good question. I like that.
Yeah, the most outlandish hypothesis.
Like any hunches or gut feelings that you're kind of brewing that...
At the moment, it's more about... I'm sort of much more narrow. I'm more thinking about the Australian flora and trying to understand. So 54 million years ago, we had this very mesic rainforest that extended all the way down into Tasmania. So you find palm trees in Tasmania, for example. The interesting thing in the hypothesis is, where are the eucalypts? Eucalypts were around 54 million years ago. We don't see them in Australia. Where were those eucalypts? And I like to think they're actually here, but they're hidden away in the middle of Australia somewhere, where the climate's probably a bit drier and a bit more, like we have it today. And so they were here, but they're just not visible at the moment, because what we're seeing is a different sample of the vegetation in the types of rocks that we see.
Going off that question around the eucalypts, I think this is a good one from Carl Borum. Thanks, Carl. What was the substrate where those Eocene eucalypts were found?
Yeah, so the Eocene eucalypts in Patagonia are growing within a crater, quite a big volcanic crater. So the deposits there are 30 to 40 kilometres across. So it's probably the scale of Taupo or something like that in New Zealand. It's a huge crater lake, and these things are growing on the flanks of that crater. And those volcanic craters are really quite interesting. There's some, they're called maar deposits, these deposits from volcanoes. And in New Zealand, there are some Miocene maars there. So Miocene's sort of, let's say they're about 20 million years old in that sort of window. And those maars have rainforest flora, a whole lot of things that, you know, are in our Queensland rainforest. Yet when you go to the sediments outside the volcanoes, what you get is you get deposits that have just got Nofaphagus and podocarps. And so even in the geological record, you can see the influence of soil and of the substrate that they're growing on, how that's influenced vegetation. And if you think of the volcanoes in Queensland today, where you've got those rainforests, you've quite often got a very different vegetation on the rainforests, on the richer soils, than what you've got on the poorer soils that are older or of a different geological substrate. So you can see those things in the fossil record, and you can see them today, and that's the great thing about this.
Wow, that bit must sort of really spur you to find those more and more relationships like that.
Yeah, yep. Yeah, so I'm working on a flora from Western New South Wales at the moment. It's in Dubbo, and you sort of think how dry Dubbo is, yet it's full of rainforest things. It's about 14 million years old. So 14 million years ago, we had rainforest out near Dubbo. Now, of course, the rainforest today is all east of the dividing range. It's in those little wetter gullies and those sorts of things. So the climate 14 million years ago was quite a bit different because it had supported that rainforest vegetation all the way out to Dubbo, you know, and that's what it is. It's about finding these deposits one after the other and filling in the story, really.
Wow, it's like putting another page in the book as you find that piece of that chapter. Stop it. It's Thursday night. I'm not going to make the weekend at this rate. I'm going to combust. There'll just be a bit of biochar left in aisle seat number 7C, and you go, oh, yeah, that's where Costa was. Tex Moon asked, is there a current eucalypt that most closely resembles the South American fossils?
Not really. We know it fits within a group of eucalypts called the Symphyomyrts. So that's a whole group inside Eucalyptus today, and that's where it's most closely related. But there's nothing that's really that we could say, oh, it's most similar to that species.
Okay. Wow, it's fantastic. Thanks for all the questions, everyone. It's unreal. The next one was from Wheezy Webb, and he or she asked, what part of the supercontinent became the most isolated and representative of the continent and not influenced by the post-breakup movement?
That's tricky because I think, all of those continents have been impacted by moving to different latitudes. You'd probably say Australia because it has quite a large number of plant groups that were Gondwanan, probably more than any of the other continents. So in that sense, the Australian flora preserves the most number of groups.
Okay. So the next one was from John, and he asked, do you have any fossil plants named after you or without going too personal like that, or by you for that matter?
None named after me. None, not that I know of anyhow, but plenty that I've named. So I've worked on several floras in in the Antarctic, there's a flora from a place called Alexander Island, and there are a few plants first collected in the 1970s. That was the first time it was discovered, and then a little bit of work done before I went down. But pretty much I've documented that whole flora. I wouldn't know. Maybe I've named 100 species out of that and other things. It's probably more. I've got no idea. It's not something I keep track of. I'm not a, you don't go, oh, there's another one. I'll put another scratch in the board. Paint another little leaf on the side of the aeroplane.
This just as a nice counter to all of this, Faye has said, it's hard enough to understand and identify the things that I find today. I cannot imagine how exciting to make discoveries from millions of years ago. I know we kind of touched on this a bit. Yeah, what's it like? It must be such a buzz. Like the timelines are just mind-blowing.
Yeah, it's a buzz, but it can also be very frustrating as well. So, I've had things I've collected and I've got no idea what that is. And you sort of sit on it. I mean, some things I've had for 10 years and then all of a sudden the penny drops and you go, that's what it is, and then you'll write about it. And some things you'll just describe and you go, I've got no idea what this is, but this is what it looks like, and these are the things that we can see. But it's those ones where the penny drops and you go, oh yeah, that's great. We know what that is. I know what that is now. I know where it fits in. I know what it's related to. So I found a fossil in New Zealand, a fossil cone that I was working on, and Araucaria, but it just wasn't right in the sections and things. And eventually we got some information and got some other bits, and it turns out that it's very closely related to Willemia, the pine that was discovered near Sydney. So Willemia nobilis. So yeah, but it took several years before that realization came, just sort of thinking about what you were seeing and what the characters were. And then it turned out that it had been described, a specimen had been described in the 70s, but the paleontologists had described it, had the whole thing upside down, so they completely misinterpreted it. But borrowing that material and looking at it, you could sort of work out what it was. So yeah.
Well, yeah.
Yeah.
Now there's a couple of comments. John, I'd just like to read this one out. John talks about tectonic movements are amazing. In North America, First Nations people call North America Turtle Island. They say the land sits on the back of a turtle. I met a fella there called Slow Turtle, which is what that land is to them. Amazing. They knew this in their own way. Maybe Oz is Rainbow Serpent Island.
Yeah, I mean, maybe it is. I mean, it's some of the things that we see. That they're hard to imagine. We had some people at the gardens that were working on Baobabs. So, this is, Kimberley, very important plant for traditional owners. And, one species here and the rest of the species are in Africa. And, and there's been a huge debate about that, is that something that people have brought in, tens of thousands of years ago, or is it a Gondwana distribution? And part of the study that some of the people at our place did, they were working with people that work on languages, and they were able to show how the language name for that thing's evolved and the genetics of it matched up with how it had been moved across the landscape. So I think there's a lot of things we just don't know. And a lot of things we just, there are alternate explanations.
Now, Dubbo with rainforest flora. I can hear the climate change cynics saying, see, it's a normal thing. Thoughts on climate change today? That's a big open question. Take it where you wish. Thanks, John.
That's an ugly one, John. Thanks very much for that. But, well, undoubtedly, we're seeing climate change. You know, we're seeing shifts in the range of species. We're seeing ecological processes be disrupted. You know, bigger fire frequencies, and that's impacting the vegetation in this part of the world. It's impacting the vegetation in other parts of the world. So there's no doubt there's climate change, and I think, you know, climate change in a geological sense is a constant. You know, the climate is always changing to a new state, but the problem we have today is that we're altering that state. And the lesson, I think, in the geological record is the Permian and Triassic period of time. So 250 million, 1 million years ago, there was a massive perturbation to what we call the Earth system, how the climate functions. Prior to that boundary, there are big coal seams being developed in the Antarctic. There's trees there. There's very wet environments. And at that boundary, we see the cessation of the formation of peat across the globe. So the globe dries out very quickly, becomes very hot, and on the other side of the Permian-Triassic boundary, we see these rocks that are called red beds, which form in desert environments. And you can actually, looking at the global geological record, you can see that starts in low latitudes and moves towards the poles. So it's a period of heating of the Earth and global change at a massive scale, triggered, we think, by volcanic eruptions, where you've got a lot of ash going into the air and a lot of CO2 going into the air from those volcanoes. And that causes a runaway greenhouse effect that heats the world, dries the world, and it is the biggest extinction the planet's experienced, where 90% of marine life disappears. Probably 70 to 80% of terrestrial life disappears. And to me, that's just a salutary lesson about how the Earth can respond to events like that, a runaway greenhouse world that you know, has major impacts, and that's something I think we should all keep in mind when we're looking at what's happening today.
Yeah, Paula just mentioned there, you know, our flora are in a precarious state. Time to prioritise Indigenous gardens rather than exotics. Yeah, it's interesting your take on this, and I had a question here from Rebecca saying, has there ever been evidence of dinosaurs consuming plants and being able to tell which ones have been browsed on?
Yeah, there's several studies looking at dinosaur poo, you know, and the sorts of things that you can do with the poo is you can dissolve it up and you can look at the spores and the pollen that are in it and see what they've eaten that way, and other bits of plant material that aren't fully digested. That's assuming, of course, you've got a herbivore. Yeah.
Well, we've still got questions coming in, and I suppose what I might do, I was just thinking, I might give out. Rebecca said, "Thanks for that." Time to start making algae taste like bubblegum, scientists, just in case. Thanks, Jacob. Tracking of here we go. The tracking of genetics of plants across the landscape and using info to show humans move plants across the landscape vast distances as well. Anything to add to that, David?
Yeah, I mean, we can see those things in, you know, a range of different groups. It's, you know, genetics is a great tool for us because we're at a stage now where we can look at things at a range of different scales, because we understand enough about which areas evolve very quickly, so you can track changes that happened recently, and which areas evolve slowly, which give us a window back in deeper in time. So yeah, there's studies that have looked at those sorts of things, and there are studies that are looking at expansion since the last glacial, for example. There was a recent paper I was just reading out on sandpaper fig that's just come out by colleagues in Sydney Botanic Gardens, and that looks at how sandpaper figs probably expanding southwards as the climate warms. It looks like there's reasonable evidence for that. And with the tools we've got today, you can do modelling that looks at what the model environment might be in the future, and you could see that sandpaper figs in 100 years or something, there'll be suitable habitat for them in Melbourne and the Prom and places like that. And I guess that's a scary thing, how quickly these things could climate can change and things could move.
Yeah, that ties in with Christopher's comment here that the Albury-Wodonga region is forecast to have the same climate as Dubbo by 2050. So the local land care networks are taking the climate change impacts into account when land regeneration is being planned.
Yeah, and I mean, we're doing the same at the Botanic Gardens in Melbourne. We've got a landscape succession plan. We've looked at what the climate in Melbourne will look like by 2050, and we're thinking about what should we plant in the gardens, and equally what things won't survive in that type of climate. So we've got to adapt, and we've got to look at what might be suitable for those future climates. The real challenge, I think, in the conservation space is knowing what to do. Which gene pools of a species are more important than other gene pools, and should we be making those judgments?
Yeah, that was my natural question there. Like, who and how are such decisions made? It's tricky, isn't it?
Yeah, it's massively tricky, and overprinted on that, you've got the patterns of genetic variation that are in there that have been that have developed over hundreds or millions of years, and now they're being subject to this rapid change, and which ones are more important. But even documenting that, we don't even have the basic documentation on a lot of that material.
Oh wow, I could keep going, but I think we've crossed over into an hour now, which is kind of like what we try and keep it. But there's always a little bit of Greek GST in there as we click up an hour and 7. And I do have a few questions to ask. Questions to ask the crowd. Rebecca reckons she's got jet lag. So yeah, we'll try and ease you back into. We'll make a slow re-entry with a couple of questions. So I thought the first question I would ask was around your discussion of the Eucalyptus, and the first person to get it in the comments, and David, you can watch the comments here, and Tim's just wrapped in there with what is also scary is the loss of the insects that pollinate our plants. Now that's 100%, Tim. I was talking about that at a climate strategy meeting today. Check doors and cross-check. Eddie says, thanks, Professor Cantrill. Best flight I ever took. Good on you, Eddie. Eddie the Eagle is with us. Hope you had your helmet on, Eddie. All right, so talking about the Eucalyptus, the question is, and it's a double banger, so I'm not giving away these prizes without checking that you were listening. So first person to drop it in the comments, and David will be so we've gone, it's officially over, and now everyone's just gene up and no masks required. Oxygen didn't fall from the ceiling on this flight. David will be the sole judge of fact. And this is the question. David was talking about Eucalyptus. I would like you to name the era, as in the scene, and the time frame. How many such and such years ago? So number of years ago and the scene for the Eucalyptus that David was talking about. Your time started 3 seconds ago. So it will be the first comment that comes in under catcher. Oh, hello. Oh, there it is. Calitotus, Ecocene 54 million years ago. Wesley Webb, the Eocene, I should say. Yes. Wesley Webb came in a close second with 54. John, 56 million. John, you're out.
Yeah.
Eocene, Shannon came through as well.
What's 2 million years between friends?
Exactly. So the first prize, Calitotus, if you can, we'll work something out. I don't know, Rebecca, we'll work it out. We'll somehow, if you can direct message, what do we do? Oh, we'll think about that for a minute. Okay, second question. You can direct message me. Direct message me with your details so I can pass them on to Rebecca, and we'll sort the prize out for you. Okay, the second question is, geez, I got so many notes here. Name at least 3 locations where the Araucariaceae have been found. And it will be the first comment that comes in after Christopher Dean. Done. Sorry, done. No, sorry, Christopher. 3 locations: Australia, New Zealand, and South America. NZ, PNG in Australia, New Caledonia, NZ in Australia. So, David, let me go back. See, gee, the answers are coming thick and fast. Thanks for being such a super fast crew here. But I think, was it Paula McGlashan, Chile?
Australia and Samoa. There may be Agathis on Samoa, so that might be a pass.
Is that a pass?
Oh, I think so. Why not?
Okay. Well, you're the sole judge of fact. I'm merely just a dodgy trying to run a competition here. So is Samoa in?
Let me just...
Oh.
It's calculating.
David's calling a friend. Oh, hang on, my phone's ringing.
Call a friend.
Dave.
Yeah, it's in. It's in.
It's in.
It's in.
There it is. So Paula McGlashan, you get the second prize, and the third prize is, well, no, the third question, I should say. Thanks everyone for jumping on. You're rocking it. Yeah, and Paula's just claiming that she did Google check. Well, Paula, I'm going to just trump Google with David. I trust David, but you got in there, Paula. And then the third and final question is, name and spell correctly the species that David found most regularly living on the side of glaciers. And it's the one after Karen. Oh, Wesley Webb. I think Wesley Webb's in. Geez, that was fast. Are we correct? Nofaphagus?
Species name's not right, but I think we can give it.
Yeah, well, that was all I had here in my notes. Was I just wanted to see Nofaphagus because that was what you showed the slide and you said that's the one. So that Google David, or David Google, has again come right to the party and smashed it out. Well, Shannon, there's been lots of comments, David. You wouldn't have seen it while you were talking, but there's actual auto captions coming out on the thing, and the casuarina has been spelled Kazzurina, and people have just been loving it, like, because he's coming up with all sorts of comments for what you've been saying, and yeah, I really, I've loved some of the G ups that people have been sharing. So what's the actual species was asked?
The actual species on the side of the glacier was Nofaphagus antarctica.
Yeah. Well, that's incorrect, because Karen Sanchez has been watching this broadcast, and she says that the auto captions says Nofaphagus.
Ah, well, that must be right then.
So Nofaphagus is the species, it's the genus, and it's correct. Because I was looking at that and I'm going, what's Nofaphagus? What's she written that for? And
that's worth a prize in itself, isn't it?
And Jacob says nothing can faze us. Jacob, I reckon that's close to a prize too. Nothing can faze us. This new species that could be when you finally get to name something.
Oh, I've got some great ideas out of this.
Yeah, exactly. It's absolutely rocking. With actually, Rebecca tells me that she sent messages to the 3 winners via Facebook Messenger. Otherwise, if you can give an email out to the 3 winners, if you can email media@biganz.org.au for those of you that don't have Messenger. So thanks for that, Rebecca. David, what a fascinating journey you've taken us on. Thank you. All the comments are coming on thick and fast. Thanks so much, David and BGANZ, for these webinars. They've been fantastic. Thank you for your time. Thank you for the journey. I could have just stayed in orbit and kept going with you, but it's been a wonderful way to cap off these 4 Thursday night chats that we've been doing. It's wonderful to see so many familiar faces here, people that have heard about it and come back each week. So a big thanks to the crowd that have joined us each night. And I suppose the main things to throw up at this stage is that this Sunday is Botanic Gardens Day. Check out what's going on at your local Botanic Gardens. There will be a wonderful discussion going on with lots of guests talking about all different topics around Botanic Gardens and horticulture on the 3CR Gardening Show, which is the AM band, if you've got that. Otherwise, www.3cr.org.au, and you can listen online. And that will be on between 7:30 and 9:15. I'll be doing a live broadcast from the Cairns Botanic Gardens. That's where I'll be on Botanic Gardens Day, which is fantastic. And don't forget to continue to explore your inner botanist and to take the Plant Lovers Challenge and share with us what plant you love and why you love it. Just put hashtag Plant Lovers Challenge, drop it out on Facebook or Instagram or anywhere online. Just put that hashtag so that everyone can find it. And what else? I think I gave the thanks. I'll just do thanks once again, given that this is our last one for this year. Big thanks to everyone behind the BGANZ webinars. Today, of course, to David, but to the panel production team, Tim Ubergang, John Arnott, Radine Koof, Alison Morgan, Helen McHugh, Eamon Flanagan, Rebecca Harcourt, and Jill Scown. Thank you very much for all the effort that you've done that has helped me to be here and coordinate it on the wheels of steel. Of course, a big thanks to the sponsors, Seasol, Augusta, Plant Health Australia, Australian National Botanic Gardens, and Royal Botanic Gardens Victoria. Check out all of their different websites so that you can see what's on at those botanic gardens around where you are. Gold Coast Botanic Gardens, Albury, Geelong, South Australian Botanic Gardens in Adelaide, Kings Park. There's gardens everywhere. So check out, and if you're traveling, make sure you jump in and check out a local botanic gardens wherever you are traveling, even more so. If you want to follow the work that David's doing at the Botanic Gardens, they have a wonderful Facebook group, which any of you can join to find out the work that's going on there, and it's RBGV Science, and that's the link that I've just put up on the screen there. So from here in Shepparton, on this final leg of the month of talks, thanks everyone for joining us, and I look forward to doing some more of these in another capacity, if not during the year. Certainly we'll take this to the next level next year. So there we have Noosa Botanic Gardens. May we have a Facebook group link. There it is, which I shared. Thanks, David, from Spencer up on the Sunshine Coast. And there's the knock at my door. So that's a perfect time for me to wrap up the broadcast. So thanks, everyone. Have a great evening, and see you at your local Botanic Gardens, or a combination of that and online for the different events that will be on the radio and on the socials over the weekend. So until then, thanks for joining us and making this a really successful series. Thanks, David.
Thanks very much. It's been a pleasure. It's been great fun.